All right, guys, here we go. Hope you're ready for some linear programming. So today what we got is a work problem that's talking about carpentry shop and creating coffee tables and dinner tables. So let's go ahead and read it together. As we read, you always want to underline, highlight some important information to get us to fully understand the work problem. So the first thing we have is that a carpentry shop makes dinner tables and coffee tables. So we're working with two things here. We're working with dinner tables and working with coffee tables. Each week, the shop must complete at least is a key word here, at least 9 dinner tables and 13 coffee tables to be shipped to furniture stores. The shop can produce at most 30 dinner tables and coffee tables combined each week. Okay, remember when we talked about those vocab words, the at least, the at most. What do we mean by those? Those are going to help you form those inequalities. If the shop sells dinner tables for $120, so we know that it sells dinner tables for $120 and coffee tables for $150, how many of each item should be produced for maximum weekly income, and what is the maximum weekly income? Okay, so we always want to summarize the problem. What is the problem talking about here? The problem is talking about creating some kind of dinner tables and coffee tables and selling them, right? So we're talking about selling dinner and coffee tables. So a carpentry shop produces them and sells them. So what is the question that's being asked? So in here, if you notice, there are two questions that are being asked. The first one is how many of each items, and the second one is what is the maximum weekly income? So how many items, so how many of each, item, and what is the maximum income? The second question is more going to come in handy with your partners and what they're going to be doing with their work. You're going to be focusing more on figuring out how do I get to that how many of each concept here. So next we're going to identify the variables. What don't we know? And remember, we always look at the question as what is the question asking from us? And that's going to identify their variables. So the question is saying how many of each. So of each, what do I know? I know that I'm creating some kind of dinner table and coffee table, right? I'm making them, but I don't know how many. So we're going to assign variables to those. So we're going to assign that X is going to be our dinner table. How many dinner tables do we make? We don't know, right? But we're going to create them. And Y is going to be coffee tables. Now you can always flip-flop those. X could be coffee tables, Y could be dinner tables. The last thing we want to do is model the situation with equations. In this case, it's going to be inequalities because we do have some constraints here. Remember when we talked about constraints in class? Okay, there's some kind of limit. Our solution has to abide by some limit. So if we take a look at our limits here, and I circled them, we're looking at the shop must complete at least 9 dinner tables and 13 coffee tables. That means we need them to make at least 9 dinner tables, and we need them to make at least 13 coffee tables. So we could represent those in constraints as X, we need to be at least, so X is going to be greater than or equal to 9, and Y is going to be greater than or equal to 13. Why did I get those? If you look at back here, we want the dinner tables, we need at least 9 dinner tables. That means 9, 10, 11, 12, whatever. We need 13 coffee tables, 13, 14, 15. So we need those to be greater than or equal to those amounts. There's one more constraint in the problem. If we go back up to the problem and take a look at what we underlined, we can see that the shop can produce at most 30 dinner tables and coffee tables combined each week. That means my dinner tables and my coffee tables, whatever I make, I need to make at most 30 tables. So I cannot make anything more than 30. So it has to be less than or equal to 30. I can't make any more than that. And what am I making? I'm making dinner tables and I'm making coffee tables. Those are our constraints. We're going to be taking a look at the income piece of it. Your partner is going to be looking more of the income. That's what we're going to try to maximize. And you'll find out what that really means to maximize an income. All right? So the next step after we form our constraints, and we want to go ahead and put them on the graph to get our feasible region. And we've done a lot of practice with the feasible regions. So let's take a look at what we have. We have x is greater than or equal to 9, y is greater than or equal to 13, and we have some kind of inequality that's in standard form. So we want to go ahead and get that into something that we can plot. We can either solve it to get into the slope-intercept form, or as we've done before, just solve for the x and y intercepts. Remember with the x and y intercepts, plug in 0 in for y. That leaves me with x is less than or equal to 30. And then plug in 0 in for x. That leaves me with y is less than or equal to 30. That gives me my points for me to be able to create my inequality graph and what it would look like. So I know I have to go all the way up to 30. Here's my graph. Now if you'll notice, I didn't give you a scale. So you want to look at your numbers and say, okay, you know what usually people do, 1, 2, 3, 4, 5. I'm probably not going to get to 30, right? So we can go ahead and go up by 2s. I think that'll be the safest choice. Don't forget to mark it by 2 so I can know you're going up by 2s. So I know my first one is going to be x is greater than or equal to 9. Y is greater than or equal to 13. So x is greater than or equal to 9, so we got 2, 4, 6, 8, 9 is right in between. So 2, 4, 6, 8, 9 is right over here. And we said x is going to be greater than or equal to 9. So we can go ahead and graph that. Remember, just 9, we need it to be a vertical line because we want it to just hit 9. Again, you should be using your rulers. I apologize, I'm not using one. Bad Mafood. Alright, the second one is y is greater than or equal to 13. Well, here's my y. I want it to be at 13. So 2, 4, 6, 8, 10, 12. Here's 13. So that's going to be my horizontal line. So we're looking at x is greater than. So anything in this area should be shaded. Y is greater than. Anything in this area should be shaded. Right? So what I want to do is I want to try to keep in mind what's getting shaded so I know at the end I know I can go ahead and find my feasible region. So x is greater than or equal to 9 was all of this area that was shaded. Y is greater than or equal to 13 was this whole area shaded. So you can start seeing my feasible region forming because I'm starting to have my green and my red over each other. Now I have one more thing left for me to graph, and that's going to be x equals 30 and y is less than or equal to 30. So we'll mark this as 9. So at 30, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And that's going to be our line for our inequality. And voila, what do you just notice right now is going to be less than or equal to. So if I go ahead and go less than, I'm going to end up in this region right over here. And that is where all of my inequalities end up over right now. Of course, this would have all been shaded blue, but I just wanted you to see that eventually this would have been my feasible region. Okay, you should have the same graph on your papers. Please make sure that you have your feasible region. You can go ahead and erase all the other shaded regions that we don't need, because what really we're going to be working with is this feasible region over here. That's really going to be our main focus, is this feasible region. Because it's at this point where all three inequalities are going to be equal to each other. Okay?